Okay, we were talking about this expected variable. Expected value, which we said that is mean, and we saw that by using this formulation we can define the nth moment. We were solving a few examples. We saw that how we can find the expected value of adding several random variables and how it affects the linear combination of random variables, how it affects on the standard deviation and variance. Let's do an example. And this example is this. Given current x, it's a random variable, so we should calculate it. We know that the average of current is 1 ampere. We also know that I will draw the schematic for this question a bit later, but let's write down the information. We also know that the power, the average power dissipated in the 1 ohm resistor is 40 watts. Find sigma square of x, which means we find the variance for the current x. And what we know is this. This is the current x. This is 5 ampere. So the current which passed through this branch is x plus 5. So if we know all the values, we don't need to know electrical engine or KCL in order to find out the values. We already know everything. Also, this is given. Power is equal to I squared R. Power is I squared R. Okay, think about it for a minute. Think about it for about a minute. So, what is power? Power is x squared multiplied by 1, right? It's I squared multiplied by R. R is 1. I is x. What do we know? We know that E of x is equal to, what is E of x? 1. It's given. The average current is 1. This is mu x. E of P is given. What is it? 40. But we know that P is x squared. Right?
Isn't this x plus 5 squared or something?
What is 5 squared?
I mean, the current passing through this 1 ohm resistor with x plus 5.
The average x is 1. Oh, the power here is, yes, it is x plus 5 s squared multiplied by 1. So E of x plus 5 squared, it is given to be 40. Now what I want to do is this. I am expanding this binomial that I have in my hand. So it will be E of x squared plus 10x plus 25. This is equal to 40. From last week, we remember this is E of x squared plus 10 E of x plus, what is E of 25? Ask what is expected value of 25? Yes. Expected value of a constant is itself. This is 40. What is E of x? 1. So it will be 35. So from here we understand that E of x squared is equal to 5. You will calculate this. Now, what we need to do, I want to find out what is sigma x squared. We know formulation says that this is E of x squared minus E of x squared. We just calculate the first term is 5, the second term is minus 1 squared, which is 1, so the result is 4. So the result is 4. Now, let's see what will happen if we have two random variables which are statistically independent. Now, let's write the theorem and also prove the theorem. Now, if x and y are independent, then expected value of xy is the expected value of x multiplied by expected value of y. And the proof is simply by writing down the definition of expected value. Now, because it is a joint random variable, so we have a double integral of xy multiplied by fxy of x and y dx dy. Now, x and y are independent of the sum. So what does it mean? It means that this is equal to fxx multiplied by f by y, right? Because they are independent. So it means I can write it as xy fxx multiplied by f yy dxy. We know that a multiplied by b multiplied by c is equal to a multiplied by c multiplied by b. In other words, I can change the location of these ones, the order. So it will be x fx x multiplied by y f by y dx dy. Again, x and y are independent. In other words, while I'm taking the integral with respect to x, the y part is constant. While I'm taking the integral with respect to y, the x part is constant. So I can write it as integral of y y multiplied by integral of x fx x dx dy. What is this one? Integral of x fx dx. What is this? This is e of x. Integral of y fy, what is this? E of y. I am sure that you understand that ex is constant, will come out, so we will be left with the integral of y fy dy. So the result will be x multiplied by e y. This is the proof. So if x and y are still a joint random variable, and if they are not independent, we have another theorem. But we will use the polarities of this theorem that I'm writing a lot. Any question about the proof of this equation, this theorem? It was pretty straightforward. The theorem says that if x and y are joint, then sigma square of ax plus by is equal to do you remember what was the sigma square of ax plus b? It was a square sigma square of x plus b is not affecting, right? Do you remember from last week? Here it is a square sigma x square plus b square sigma y square plus 2ab sigma x and y. This is covariance. This theorem, we don't use it directly. What we use is this. The corollaries, the consequences, the conclusions that we get from these theorems, there are two of them. Corollary one. If x and y are independent, what do we expect to see? They are not affecting each other, right? Which means that the sigma square of ax plus by is linear combination of the variances. Note, if a is 1 and b is minus 1, we get this. Sigma square of x minus y sigma square of x plus sigma square of y. In other words, if we subtract two random variables, two independent random variables from each other, their variances will be still added to each other. The variances will not be added. What would they mean? What would they mean? We should subtract that. Because we have s squared here, where in the mean we don't have the s squared. We have a mu x plus b mu y, and b is minus 1, and minus 1. Now, from this theorem and this corollary, we will get another conclusion, which we will use it in the next example that we want to solve. So let me write it. Here we have two random, independent random variables, right? If our whole if we have k random and k belongs to 1 till n, if we have all our random variables, lots of them, to be independent, then for x to be the addition of all of them, we have the variance of x is the summation of the all variances. When we had only two, we are just adding them. If we have more, we will add all of those ones, which we are using in the example that we have now, and the next example which we are talking about the binomials. For x and y being independent random variables, we have sigma is square root 2 and sigma square y to be 3. Find variance of a random variable like z, which is 3x minus 2y plus 5. So we have two random variables, x and y. They have been combined and make the random variable z, and we want to find the variance of z given that variance of x is 2, variance of y is 3. So how do we do it? Which will be 9 multiplied by 2 plus 4 multiplied by 3, which is 18 plus 12, which will be 30. is about probability model for computer engineering. Now, you know that the computer is a digital world. So in other words, we are dealing with zeros and ones. So it will be very natural that we pay quite some attention on something which is called binomial distribution. The term bio means it's dual. It has the base 2. It's 0, 1. So let's see what are the binomial distribution. How we can call something to be a binomial distribution. Do you want to wait or you check it? Okay. Now, a binomial distribution will be defined for those type of events which has only two outcomes. And these outcomes can be referred as 0 and 1, success or failure. So, assume we have n repeated Bernoulli or binomial traits, and they are x1 to xn. And each xk has two outcomes. Known as 0 or 1. We call them like success or failure. So we have only a binary decision with probabilities of P and Q. We know that P and Q are complement of each other. So it means that Q is 1 minus P. Because the addition of the probabilities should be 1. So this is the probability of success, which means that the event is 1, and Q is when it is 0. So for this binomial distribution, for any xk, what is E of xk? What is the expected value of xk? It will be summation of xi's multiplied by over I. Can you tell me how many outcomes do we have here? Nastia, how many outcomes do we have? No, 2, because it's binomial. So we have only 2. What are they? They are zeros and 1. So it will be 0 multiplied by fx of 0 plus 1 multiplied by fx of 1. Now, what is fx of 0? The probability of failure. What is it? Q, 1 minus p. 0 multiplied by 1 minus p plus 1 multiplied by p. 0 multiplied by whatever it is 0, so it is p. In other words, as it is a binomial distribution, the E of k, the expected value of E of xk is p. E of xk is p. Okay, maybe you want to try what is the variance of xk. We know that it is defined as expected value, right? Which means that it is now, if it is Mortensen, if it is 0, what was mu? P. Plus, if it is 1, so it will be minus P. What is F0? What is F0? Q, or 1 minus P. I write it as 1 minus P. What do you want me to write as Q? Let's give it as Q, and then we can replace it with 1 minus P. Plus 1 minus P. What is F upon? P. Now, let's see. Let's see. Small mistake. Square, 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 square. This is S square. So it will be P square Q. 1 minus P was, what was 1 minus P? Q. Plus Q square P. I am factorizing the PQ. So it's P plus Q. Do you agree with this? Nastia, do you agree with this? I am just picking the PQ out. P is that from here, Q is that from here. Now, next one. What is P plus Q? So what is it? So what is it? What is the value of that probability? 1. Is PQ or P multiplied by 1 minus P. Now, so we know for each K, and we said that we have this Bernoulli trail, which means that we have n of these xk's. Let's see, in that case, what will be the expected value and what will be the variance? Finish writing? Now we want to use the previous theorems that we have written in order to find out what is E of x, which is E of summation of xk's. Now, they are random, they are statistically independent. So how many of them do I have here? How many of them do I have here? N. So it will be like because they are statistically independent, we know that this is P, and we have n of them, so the result is NP. The result is NP. They are statistically independent. So what can I say about this one? We just show that this is equal to that. Here starts from 1 to n. What was this one? P cubed. How many times do we have it? N times. So it's n p cubed. Let's do an example on the discrete joint probabilities and we will some calculations. Roll 2 fair dice and we call them dice 1 and dice 2 and we say that X is the outcome of dice 1, which is the first dice, and y is the outcome of dice 2. What is part A? What is the joint probability function? B. What is the probability that x plus y is greater than 10? Okay. You want me to stop the tape recorder? Now, let's see, Nastya, what is the definition of x, y, and x and y? What does it mean?
Well, in this case, since they are
No, in general, what is the meaning of x and y? X and y.
the summation.
No, it means the probability that the random variable x is x and the random variable y is y. What is the meaning of the comma? It actually means the probability that x is x and intersection y is y. Now, die 1 and die 2, can you tell me that how correlated they are with respect to each other? How much they depend on each other? They are independent. They are independent from each other. So it means that this is the probability of x is equal to x multiplied by the probability of y is equal to y. Morteza, what is the probability of number x when I am dying a die?
1 over 6.
1 over 6. Multiplied by 1 over 6, so it is 1 over 36. So this means that f of x and y is 1 over 36. What can you tell me about this distribution? Exactly, it's a uniform distribution, as we were expecting to see. Now it continues in the next part. It said that what is the probability that we have x and y to be 10? So it means that tell me the values for x and y which addition is 10 or greater than 10. What is the value of a? If we have 6, 4, 6, 5, 6, 6, if, right? If I have 5, 5, 5, 6, If I have 4, 6, they are the only values, the only possibilities that I can have. The first line is 6, so the next one can be 4, 5, 6. If this is 5, the next one can only be 5, 6. If this is 4, the next one is 6. So, here, for this part, we want to find the probability of x plus y is greater than 10. In other words, it says find the probability that x and y belongs to A. What is this probability? 1, 2, 3, 4, 5, 6. I have 6 cases. What are the total cases? 36. So it will be 1 over 6. It will be 1 over 6. Let's do another example. Any question? Aster? Murtaza? For a binary communication channel, we have find the marginal probability is of fx and fy. So in order to solve this example, we have to remember the definition. Peshwa, do you remember what was the definition of a marginal probability? For instance, what is the definition of fx6? It means that, look at the joint probability. What will happen if x is fixed and y is changing? Now, in order to do that, we have to look at the table. Actually, the calculation is pretty simple. Here, let's look at this one. Can you tell me that what is fixed? Y is equal to 0 is fixed. And x is changing. So it means that this is f of y, because y is fixed for 0. And it is the addition of all the joint probabilities when x are changing and y is fixed. Because my y is fixed. So this is f0, 0 plus f1 and 0. Right? What about this one? What can I say about this? This is fy1, which is f01 plus f11. So I have found fy. What about fx? Yes, we have to look at the column. Here, x is 0, so I have fx 0. This is f00 plus f01. Here I have fx1, which is f10 plus f11. What is the success probabilities if X is transmitted bit and Y is the receiver? Now, it says that, let's just wait for a second. I promise you I will let you to write everything down. The scenario is this. I am sending X and I am receiving Y. The question is, what is the success probability? Now, can you tell me also what is the success, the scenario success? What is that?
It means just we are receiving the same bit as was sent earlier.
Yes, so the success is this. I am sending 0 and I receive 0. I am sending 1 and I am receiving 1. So in other words, the question is, what is the probability of? I will tell you right now. X is 1. Sorry, Y is 1. Given that X is 1 plus the probability of X is 0, my bad, Y is 0, given that X is 0. What is the additional probability of I'm receiving 1 if I am sending 1? What is the probability I am receiving 0 if I am sending 0? Do you remember? What was the formula for this one? This is f of divided by, isn't it true? What was the name of this formula, Astia? Pi epsilon. So it means that this is equal to f11. What is fx1? I just calculated it. F1 and 0 plus f11. What is the probability of y is 0 given x is 0? It is f of 0, 0 divided by fx0, which is given f0, 0 plus f0, 1. In other words, the probability of success is the addition of the probabilities that I have just calculated. So it's f1 and 1 over f1 and 0 plus f1 and 1 plus f0, 0 divided by f0, 0 plus f0 and 1. Wait, visual. Now, we shall talk about the probability, this type of probabilities, calculate the probability of errors, because these are the scenarios that we have when we are communicating, let's say, between two terminals. We will see, and we will show a few more examples on our next lecture. Do you have any question? If you have no questions, it's the end of the lecture for today.